did. Obviously, the key word on this whole page is the word product. You see it all over the place. So, I would think that it would be super important for us to understand what that word means. So, what mathematical operation is indicated when we use the word product? Multiplication, that's right. So, multiplication, there we go. So we're just going to go table by table here. Noel's table. Somebody from Noel's table. So, Coy, Callie, Anna, Faith, Jaden, somebody. Number 1, what do you think? Yes or no?
No.
So, hey guys, hey. Pay attention. This is going to be super foundational for you. The answer for number 1 is no. What is number 1? It's addition. It's not a product, right? It's addition, so it's not a product. Number 2, this table right here, yes or no?
Yes.
Yes is correct. It's 2x times 3 minus x. Number 3, let's go with our back table.
Yes.
Say yes. Yes is correct. Well done. Okay, number 4, your table.
No.
For number 4, Joe's right. The answer is no.
Oh.
Kyrie's right. Kyrie, you're right. It's addition. It's addition. So, everybody, hey, listen up, please. Looking at numbers 1, 2, 3, 4, seeing the correct answers. Will you guys now look forward to your 5, 6, 7? And I want you to make a decision. Do I need to change 5, 6, or 7, right? Now that you maybe know a little bit more than you did a minute ago, would you go back and change anything on 5, 6, or 7? If you would, go ahead and change it. If not, just leave it. We'll see how it goes. So rethink 5, 6, and 7. See if you really think that they're correct. Or maybe you need to make a change. I don't know. Okay. So for number 5, what do you think? What do you think, guys? 5. Yes or no?
No.
You say no? 5 is a solid no.
It's a maybe.
Agreed. Number 6, Coy's table. What do you guys think?
Yes.
Number 6 is a yes. I hope you're listening, I really like to compare 5 and 6. Do you see how 5 and 6 look really similar?
Yeah.
The only difference is you got this plus sign stuck in there, whereas this is multiplication. But otherwise, they look incredibly similar. Somebody might even think they're the same, but they're not. They're very different. Okay, last one. Back table. Yes or no?
Solid yes.
All right, we'll go with a solid yes. That is correct. So, do you understand the point of this? Telling you the difference between addition and multiplication. Sometimes people struggle with that. Okay. Any questions? Any questions? No? Okay. All right. Hey, guys. So, the intro video kind of went over this, and I have to admit that I am relatively new to the methods that you saw in the intro video. It's only been in the last several years that I've decided that I really like the method that you saw in the intro video. I call it the box method. 6th, 7th, 8th grade teachers have their own names for these. I've heard the word lattice thrown out there. I just use boxes. I don't really care what you call it. I think it can be very effective, okay? I don't even think this is really lattice. Some people see this like, oh, it's this. And I don't really care what you call it. It's just a nice, really organized graphic organizer to get you to a good place. So I wanted to kind of review this with you a little bit from the intro video and see how you're doing. So if you guys would, please try number 1. I think number 1 is really similar to one of the ones you saw in the intro video. Use your boxes and try to figure out what 3x squared times x minus 7 would be. So we're flipping over to this page. Ready, set, go. You're going to just have to wait and see. Guys, let's take a look at number 1. I can see that most of you have made some progress on number 1. So number 1, what I would do, I'm multiplying a monomial times a binomial. So I need 2 boxes to do this. 3x squared would go here. X minus 7 would go there. And all you do with these, because we're doing multiplication, and again, when you're talking, I feel like maybe you're not listening. I hope that you are listening. This box method is only for one operation, and that's multiplication. If you're trying to add polynomials or subtract polynomials like we did yesterday, this would not work. This is specifically for multiplication. Here's how it goes. Wherever you see an intersection of these two, you just multiply to fill in the box. So 3x squared times x would be 3x to the third. That's right. And then negative 7 times 3x squared would go there, and that would be?
Negative 21x squared.
So take a look at that. All we then have to do is rewrite this outside the box as our official answer, 3x cubed, minus 21x squared. The nice thing about this box method is it really doesn't matter what types of things you're multiplying together. You just make your box bigger or smaller or rearrange it and make it look a little bit different. It's just a nice graphic organizer, Ben.
Do we have to use that?
So I am foreshadowing something. So in our next unit, we're going to talk a little bit more about exponents. And then soon thereafter, we're going to talk about something called factoring. And I will show you factoring using the reversal of the box method. So I do want to let you know, like, there are certainly way more ways than what I'm showing you how to do this. And I am not going to require you to use the boxes. I am going to require you to use like a coherent, intelligent way, right? If you refuse to use the boxes, factoring might go poorly. It might not. I don't know. Just know that I'm leading into that factoring with this. I'll be consistent. That make sense?
Yeah.
Okay. All right. Number 2. So for number 1, we needed a 1 by 2 set of boxes. For number 2, what do you think we'll need as far as our boxes go?
Those 2 by 2.
2 by 2, right? Because it's a binomial times a binomial. See if you can do that, all right? So set up your 2 by 2 and see if you can multiply here. Number 2. Ready, go. If you're wondering about how to set this up, I've set it up there for you. Your 2 by 2 box. I decided to put the first one on the top and the second one on the side. You could have gone the other way, and that's fine.
I don't know how to set it up.
So looking at what I have, does that make sense? Or do you have questions about why I did what I did?
It makes sense. It just, I don't know. I'm not very good at it, I guess.
Say it one more time.
It makes sense. I'm just not very good at it in practice.
Okay, well, let's practice. Keep going. If something is confusing, right? If I write something up there and you're like, what? I thought it was this, and you wrote that, just say something. It's okay.
On this one, you have 1 on the outside.
Yep.
I guess I don't know what to really do with that. So I know you would put that there, right?
Yep, and we really only need 1 row, but we would need 3 columns, right?
Yeah.
Because we've got the 3 terms that we're. There you go. Yeah, that's your setup for that one.
Okay.
And then, so that would be, I would call this like a 1 by 3. What would we do here? What would we need for number 4?
I didn't use boxes on any of them.
And 2, so would you need?
To show you guys.
I'm sorry.
I want to say. I want to say either 2 or
I
3.
didn't see it. I got it.
So it's a binomial for the first one, right?
Yeah.
So it'd be 2 rows, and you have a trinomial for the other factor.
So it would be 2.
2 rows by 3 columns.
Yeah.
2.
Okay.
Keep playing around with it. See how it goes. Okay, number 2. Again, look at what I have up there as far as a setup with your graphic organizer. Does anything seem confusing with that? As far as
did it like opposites, like 5x.
yeah, you could have put the top and the side and just swapped them, and that'd be totally fine. Yep. Either way, we'd end up with the same upper left box, right? So that upper left box is 4x squared times 5x. Anybody have a suggestion what you think that might be? 4x squared times 5x? 20x to the third is right. Very good. Okay. So then if I multiply this times this, 5x times negative 3. Again, any suggestions there? Negative 15x is right. That lower left corner on mine is actually really easy, right? Because it's just times 1. So it'd be 4x squared times 1 would just be 4x squared. And then that lower right is similarly pretty easy, right? Just negative 3 times 1 would be negative 3. So again, remember, math should make a lot of sense. If something I did up there is confusing you, maybe you're wondering why it's x cubed or something. I don't know. If anything's confusing you, totally get it. We're doing something kind of new. I'd understand. Just ask. Okay, then the final step would be to write this out in the correct format. So it would be 20x cubed plus 4x squared minus 15x minus 3. So make sure you write your answer outside your boxes. That's just a graphic organizer to get you in a good spot. So number 3, yeah, you need a 1 by 3, right? So let's take a minute and try number 3. Ready, set, go. Number 3. Number 3, you're multiplying a monomial times a trinomial. So it'd be a 1 by 3. I'll give you a look at it up here. So if you want to get a look at what that graphic organizer should look like. Hallie, what do you think? Have these done?
Good job.
Pretty doable? Tired? Bragging or just feel sorry for you?
Kind of a little bit of both.
I was struggling with that.
Practice is a never done this. I don't know what you then for the last so usually we have practice.
For what?
Tuesday, Friday.
6. So 24 minus 30.
Why did you last
Literally, I just knew
Okay, I'd love to hear from Witt's table on this one. For that first box, what do you guys think should go in that first box?
6x to the 5th.
6x to the 5th is correct. What do you guys think for the middle box?
24x to the 3rd.
That's right. You guys listening? These guys are knocking it out of the park. Final box?
Negative
30x
30.
cubed.
Squared.
Oh, so you do that actually. Okay, so now I know how to do that.
Does that make sense?
Yep.
Okay. So you'd write this off to the side. Did you all get 6x to the 5th plus 24x to the 3rd minus 30x squared?
Yes.
Okay, fantastic. So that was a 1 by 3 because we're multiplying a monomial times a trinomial. Number 4 would be what kind of box?
2 by 3.
So please try to set up a 2 by 3. I'll set it up here too. You can look at it. We'll check your answer here in a minute. Yes, ma'am.
I kind of went ahead, but you set these up like you would the other.
Yes, that's so perfect. That's a good find. Well done.
Because you always do that whenever we square stuff. I just did it.
Yeah, you got to understand what squared means, right? As soon as you understand that, you're in good shape.
And I do remember because I learned
this more foiling than
Yeah, so
It's a little bit harder.
so here's the thing about that. I have used foil many times, and I have found two things with it. As soon as you move away from a like a binomial times a binomial,
Yes.
people freak out. They call everything foil, and they don't know how to deal with it.
Yes.
But if we just use boxes for everything,
It's so much
it's
easier.
consistent,
So
right?
yeah, this
Yeah.
makes a lot more sense. That's,
And then, like I was talking about with Ben, when we get into factoring, is basically when we actually reverse all this stuff, we'll just stay consistent and we'll use the boxes to reverse it all, and it'll be in a much better place. So this has worked well in the recent years. Hopeful that it'll be good for
yeah,
you
but
guys too.
connecting this to this.
Yeah, agreed. Seeing it's the same thing, just a different method. Okay, I'd love to hear from Victoria's table. Guys, listen up, please. Let's see how they did. Upper left box, Victoria's table, you think that it is? Oh, swing and a miss. What? Upper left-hand box?
Oh,
X to the fifth.
X to the fifth. Excellent. How about the upper middle box? It's going across to the right here.
Negative 2x to the third.
Negative 2x to the third. And then the last box on the right there on the upper part. Okay, do you all agree with that part of the box?
We do.
Yes.
Okay, very good. Let's come over here to Faith's table. Let's do that bottom row. Lower left. What do you guys think? 3x to the fourth. Jaden, what do you think about that middle? Shh. Quiet, please. Middle lower box.
Negative 6x x to the second.
Awesome. Okay, and then lastly, that lower right-hand box, everybody? Yay, good job. Okay, so 24. And then it does not appear that any of the terms in those boxes are like terms. So there's no combining we could do there. But I could write the answer off to the side here, which I need to do. It'd be x to the fifth plus 3x to the fourth minus 2x cubed minus 6x squared plus 8x plus 24. So kind of a longer expression there to write out, but it is what it is, right? Any questions so far? Is this going all right? You seem like you're doing pretty good. The last one I'd like to do with you, but I want you guys to help me out because number 5 says parentheses 2x minus 3 squared. So to get us started here, I want you guys to understand something. This can be, it's not really intended to be, but it can be sort of a trap question. I've seen people do this. What I'm about to show you is totally wrong, but it's a common error. So check this out. I've had people do this. Here's what they're thinking. Oh, okay. Well, 2x squared. Well, 2 squared is 4. X squared is x squared. And they get this. And they say, well, negative 3 squared, that's 9. So I'm done. This is wrong. This is wrong. What we need to understand, guys, hey, those of you that are just chatting or talking about, I don't know what, this is a very poor timing, okay? People that do that, we totally get why they would do that, but unfortunately it's wrong. Here's what you need to understand. We need to understand what squared actually means. Can you explain what that means, anybody? What does it mean, Josh?
it's just 2x minus 3 times 2x minus...
Yeah, the base times itself, right? So what this really means is 2x minus 3 times 2x minus 3. Do you see now how this really is one of those box questions like we've been doing?
Yeah.
So take it from here if you would. Get the boxes set up and see if you can multiply this out. Ready, go.
We can, do like, so, there you go. So, that's negative 8 plus 9, or negative 8x.
Okay, I want to hear from Ben's table here. What do you guys think the upper left box would be?
4x squared.
4x squared? What about the upper right? What do you guys think?
Negative 6x.
Negative 6x is right. Lower left?
Negative 6x.
And last one.
Negative, or positive 9.
Look at the box that they have. Look at the box that you have. I hope that they agree because that's right. What is the one unique thing about number 5 here that we are going to be able to do that we couldn't do on all the other ones? Yeah, 2 of the terms are alike, aren't they? So these 2 terms, I'll just tell you right now, frequently, sometimes those terms will be like terms. Today it will only happen once, but it'll happen again. It'll happen on other situations. And so just be aware of that. So when I write this out as my answer, it would be 4x squared. What is negative 6x plus negative 6x? There we go. And then we put in the plus 9 to finish it off. It's in descending order, and we're good. By the way, if I was going to name that polynomial, I would call it a trinomial. The degree would be 2. The lead coefficient would be 4. So that's old stuff, but yeah. All right. Great job.